like to talk about how I started with this. Believe it or not, first and foremost, I'm a farmer. I came to this country about 30 years ago to become a farmer, get a degree, and go back to South America to farm. And one of the amazing things about these countries is that when you study to be a farmer, they actually teach you a lot of genetics, since you need to know about breeding and things like that. And when I started taking those classes, I was told that I was pretty good at that. So instead of pursuing a farming career, when I finished with my bachelor's in agriculture and agronomy, I went to graduate school to study genetics. So I got a PhD on that. And then very quickly, once I got into that field, what ended up happening was I started working for a number of companies that did a lot of genetic testing and related things. And eventually what happened after working for a number of those companies, I got myself in an opportunity where I was able to start my own company. So for the last just a little over 15 years, I've been running a biotech company that does basically the DNA testing, the kind of testing that you see a lot of nowadays for this COVID-19 virus.
So how did you get interested or about COVID-19?
That's a good question. I like a lot of people, I'm sure, maybe 2 or 3 months ago, you didn't even think about this. I mean, I was just going on with my life like everybody else. And all of a sudden, you started seeing that more and more cases were showing up. And then, of course, we started having cases here. And what I guess the main reason why I really started getting deep into what was going on was the fact that on one side, we had people saying that this was not real. And a lot of things that we normally used to do when something like this happened were not being done. So and because again, it's a field that I'm very familiar with, I started doing research of my own. And so that's where my interest started. I would say that I really got going looking at this stuff maybe a couple months ago.
And so you said some of the things that are normally done were not being done. Could you give us an example?
Sure. I'm sure a lot of people forget that we get these pandemics, maybe not as bad as this one, but we do get pandemics on a regular basis. We had the H1N1 one just 10 years ago. We have SARS, we have Zika, and we actually have a number of these also around the world that we never hear about. And I like to follow the world news in addition to our local national news for a number of reasons. But so this is something that happens all the time. And what normally happens when something like this occurs is that countries start implementing a series of measures to make sure that we get prepared for it, that we make sure that it doesn't spread. And other countries were doing that, but for some reason we were not.
Mm-hmm. So can you give us a history of the pandemic?
Sure. One thing I like to mention to people when it comes to this pandemic is that we all call it COVID-19, and that's fine. But the brother of this virus is called SARS-CoV. CoV is COVID.
Mm-hmm.
SARS being severe acute respiratory syndrome.
Mm-hmm.
So what we're really talking about here is a severe acute respiratory syndrome coronavirus.
Mm-hmm.
And you know, everybody talks about how this is a novel thing and all that stuff. We had a SARS coronavirus about 15 years ago. It went all over the place, over 20 countries, it infected thousands of people, and not quite 1,000 deaths. So obviously, I wouldn't be surprised if most people don't even think about it or remember that. This one happens to be the second one. And the only reason why we call it COVID-19 is because it was first identified last year, so 2019. So COVID-19, just because everybody calls it that. The first case was identified in China in November of last year. And everybody has heard of Wuhan and how that place was shut down and they were able to control it and all that. And a lot of people have heard of these wet markets and how when you have wet markets, you essentially create the perfect environment for viruses to jump from wild species to our food chain, and then people get infected and all that. Now, is it possible that that's what happened here? It's possible. It has been documented in the past that some of the pandemics that we've gotten in the past came as a result of jumping in wet markets. In this particular case, though, while that was the original thought, it's more than likely not the case. What happened was, and without going into too much technicality, we are pretty much sure that this is a bat virus. So it came from a bat. The reason why we can say that is because this COVID-19 virus is 96% identical to a virus that we know of that we've studied in a bat. So that tells us, okay, this came from a virus. Now, from a bat. Now, why is that important? Bats, not only are they, of course, wild animals, but bats are also consumed all over the world. And bats happen to infect a lot of animals. And one of those animals, and again, this is the current thought in the research field, is that a bat somehow infected a pangolin. If you're not familiar.
Pardon me, what did the bat infected who?
Pangolin.
Okay.
And again, most people in this country are not familiar with pangolins. Pangolin is arguably the most trafficked animal in the world. They are critically endangered. And the only reason why people love to get their hands on these little animals is that they're considered a delicacy. People, it's very expensive. They like to eat it, and of course, a pangolin is actually it's a crazy looking animal. It's a small. It looks like a dinosaur, but it's a mammal. So it's a mammal. It's a mammal that has scales all over his body, and when he tries to defend itself, it crawls up into a ball that looks like a rock. So people eat the meat because when you are an animal that has a hard outer protection layer, your meat tends to be very, very delicate, very soft, because it doesn't need to be hard because your heart's outer surface protects you. That's why sushi is as soft as it is, and you can make sushi out of fish. And those scales, because this animal has been trafficked for millennia, are used for all sorts of medicines and whatnot. So the current prevailing theory is that what happened was you get the bat infected a pangolin, somebody ate that pangolin, and that's how it started. So that's kind of like the way it started. Now, a little bit of pop culture. If you remember the movie Contagion that came out in 2011, that is a very good representation of what's going on right now with COVID-19. And I'm not surprised that if you have a Netflix account, that movie is all over the place right now. So that's how it started. And then there's a lot of research, a lot of publications right now showing how this whole thing spread. They characterized all the first few cases, the lady, Chinese lady that started the whole thing and all that kind of stuff. Then he went to Thailand, then South Korea, then he came here, France, and the unfortunate thing about all the different information and stories and trying to understand where this came from is that we are essentially coming up with explanations and stories based on very little data. A few places have done a lot of testing. So for example, Korea has a very good grasp of how the whole thing happened in that country. But outside that, a lot of what you see about where did it go first, where did it go next, is a lot of speculation. It's, yes, we have some data. It suggests that this is the case, but you almost for sure, months from now or a year from now, you're going to start seeing a better explanation of what really happened. And right now, it's yes, it's spreading all over the place. How it's doing that, where it's going next, it's kind of tricky.
You said that Korea had a good grasp on the situation. How is Korea different? How did they get that grasp?
They did exactly what we did when H1N1 came here. If you remember, when H1N1 started, and it started in Mexico, we started immediately, and we tested over 1 million people in less than a month. And that's exactly what Korea did. What Korea did is, as soon as they saw a case in their country, they started testing by the tens of thousands. And because of that, they were able to identify every single case and stop it before it even started to spread.
So what do you think Dr. Fauci is most worried about when it comes to the disease?
Dr. Fauci, I love the guy. When it comes to Dr. Fauci, one of the things I like to point out is something that if you listen to him long enough, or if you've listened to him over the years, he'll tell you this. When people ask him what is he worried most about when it comes to diseases that originate and start spreading and all that, what he says is, I worry about diseases that spread easily. I worry about diseases that can cause a lot of mortality and a lot of morbidity. Now, a lot of people understand mortality when people die. A lot of people don't understand morbidity. Morbidity is a disease that is capable of causing a lot of disease symptoms. So in this case, it's easy to think, okay, well, we're thinking that maybe 1% of the people are going to die. And you're like, well, that doesn't sound too bad. But morbidity is a much larger number in this particular case. And these are people that are going to have to go to the hospital and be treated for very bad health conditions. And the reason why that is a big deal is because once you go beyond a given number of people having to be hospitalized, you overwhelm the system. And when you overwhelm a system, you start spreading the disease way more than it should be, and then it becomes a really big problem. And another thing that Dr. Fauci likes to always bring up whenever people ask him about this is not just that it spreads a lot and that it has high morbidity and mortality, but that it lingers.
Mm.
And for example, you can have this virus, remain in surfaces for days.
Mm.
You can have this virus basically float in the air for minutes after somebody sneezed and left the room, and then you come in and you basically don't realize that what you're doing is just breathing that same virus. Essentially, what he says is, when you get all these factors together, this is a worst case scenario.
Mm.
Now, if you look at whenever you see him on TV, you never hear him say that. But if you look at those interviews that he does on the side, he mentions this all the time. And I understand what he does. I mean, nobody wants to create unnecessary fear.
Right.
But sometimes you need to basically tell the truth the way it is, because unless you do that, you start falling behind, and then you have to increase the severity of your statements to continue catching up to the worsening problem.
Mm-hmm. So why do you think we fired the pandemic response team?
Well, I'm gonna do my best not to get into politics here. I'm gonna give the administration the benefit of the doubt and basically say that they were just trying to cut costs.
Mm-hmm.
I mean, they fired a lot of people, right? I mean, it's clear that they fired a lot of people. And I mean, I read somewhere that the president said, I don't want to have, thousands of people just sitting around in case something happens, right?
Right.
And, there's some value to that. Now, in this particular case, I would argue too that sometimes if you're trying to get ahead of something, you need to be proactive instead of reactive. Being reactive to a lot of things works. I mean, if the stock market goes crashes, there are measures that the banks and the Fed and all that kind of stuff can do to try to alleviate the problems. But when you have something like this, where it can spread so quickly, if all you're doing is reacting, you are going to be spending many more times more resources just trying to keep it under control than you would have if you had been proactive and stopped it early on.
So why were the other countries in the world faster at getting the test out? For example, Korea.
Yeah, that's actually, unfortunately, a story that we will likely not know the whole story until later. We, as a country, have been very good in the past at putting together the best tests for this kind of pandemics, and then share it with the world. I mean, when, again, and I go back to the example of H1N1 10 years ago, the CDC designed a test for H1N1 before we even had a single death in this country, and share it with the rest of the world before even the World Health Organization said that it was a pandemic. I mean, this was all done very quickly, right? Now, the funding for the CDC, who is typically the one that designs this assay, has been cut. As a lot of, again, as a lot of things have been cut. And when you cut that much to a research organization that is in charge of doing something like this, what happens is you lose a lot of the people that are competent, that know how to do this stuff. Now, these people, like anybody else, have lives. So they basically are told that they are not needed, and they either quit or they get fired and they go to industry. Because these are very capable people that have knowledge that can make a lot of money for companies. So we basically took that expertise, moved it somewhere else. They are doing fine in the places that they're working on, and they're developing those same type of assays for any myriad of uses that those assays can be used for outside pandemics. And the people that were left, and again, I'm sure they were good people, but maybe not as experienced. Those people designed an assay. And as far as I can tell, because again, unfortunately, that information is not being shared with anybody. So there are people that know what happened, but we don't know exactly what that was. Those people that designed that assay made some classical mistakes. You could even call it rookie mistakes. And they decided that the assay that they designed was good enough without doing the proper testing. They put it out, it failed. And that's why just that alone could easily explain why we were so late to the game. Let me. I know a lot of people don't tend to tune out when you get a little technical. Let me get a little bit technical here. So when it comes to tests, so this virus, like a lot of viruses, this virus is only its genome. The RNA that makes the virus is only about 30,000 pieces of DNA information. DNA is made out of nucleotides. There's these little units of information, A, T, C, G, and it's 30,000. That's all it is. It's a time. For context, we humans, our DNA that makes us is 3 billion units of information long. So when we design an assay like this, we take a little piece of DNA, usually no more than 20 or 30 units long, and we take one piece on one end, one piece on another end. So we expand a region out of those 30,000, which could be as little as 100 to 200 units of information spanned by those two pieces of DNA that we design. And then we take those two pieces of DNA, you put it in a reaction called PCR. And that PCR reaction, all it is an enzyme that takes those two DNAs and makes copies of it. So one cycle, you turn one copy into two copies. Second cycle, two copies become 4 copies. Third cycle, 4 become 8. And just by doing that, in 30 minutes to an hour, you can go from 1 copy to 1 billion copies in just 30 cycles of that. And that's all it is. Now, this is where it gets tricky. When I design one of those primers, this piece of DNA, to make this assay in a human, I have 3 billion, I have a whole world map of possibilities because I have 3 billion pieces of units where I can pick and choose wherever I put that little piece that I'm going to design an assay for. In a virus like this one, you only have 30,000 pieces of information within which you have. it's very easy to go through all those 30,000 units and not find something that is good. And I'll add even another layer of complexity. Viruses like this one have been attacking the human species for millennia. Our genome, the DNA that makes us, is like the surface of the moon. It's full of craters, full of battles that we fought for thousands of years. So this virus infected us, this virus infected us. I mean, every human being has a history of every single disease that our ancestors battled. And those scars are little remnants of that DNA that virus was able to get in there. So if you remember that alone, and you're trying to design an assay on those 30,000 pieces of this coronavirus, and you don't go into our 3 billion unit of information genome to look to see if there's anything there of another virus that was attacked us 1,000 years ago, and it just so happens to have a little bit of similarity to the DNA of this corona, and you design an assay, and just by bad luck, it contains a similarity to the DNA we already have because there was another virus was there, then you're gonna get false positives.
Right.
And that's possibly one of the many reasons why the assay that we designed failed. Now, how is it that these assays are typically designed? There's a lot of ways to do it, but one very standard classic way is you design a lot of them. You design, even if you use every single tool that you have to design the best assays, you don't design just one, you design 5, 10, and then test them all at the same,
right?
Exactly. And then you choose the best one. And that's more than likely what all the other countries did that enabled, especially Germany, that enabled them to get an assay within a week of the Chinese getting the sequence of this virus. And they already had an assay ready to go that to this day has shown to be very effective.
So why didn't we just use the assay that, I think, what did they sequenced it January 11th? Right. They did a sequence of COVID-19 January 11th. And then Germany developed the test and shared it on January 18th. Why didn't we just use the one that was already designed?
Okay, so that is definitely a question. Let me say this. I mean, because before I even started talking to you today, I had a conversation with someone that was asking me about what's going on with this. And unfortunately, this individual, like a lot of people, and you could argue that there's some fairness to it. A lot of people are blaming China for what happened, right? Because it started in China, so therefore China is to blame. Okay. Let me say this, and I'm not gonna side with anyone here. The second that China identified this, they sequenced the genome of the virus and they shared it with the world. And they say, look, here it is. So, and that was, like you said, January 11th, right? So if China was indeed, doing some people were saying that this is a weapon that was engineered somewhere, which, as a geneticist, it blows my mind to imagine that we humans have the capability of designing something like this. But the fact of the matter is the Chinese got this virus sequenced immediately and share with everybody. So that was very useful. Without that, anything that happened since then would have never happened. Now, the Germans, of course, took that information right away and designed it and developed the assay. Now, and then the WHO, the World Health Organization, essentially used that assay as the benchmark and say, okay, here's the assay that we approve. Everybody can use it. Right? Now, why didn't we use that assay? I don't know. I mean, I would say that we do have a tradition in this country to go our own way. We know better. Maybe there's a little level of pride that we have the technology. I mean, arguably the United States is the leader in everything to do with biotechnology and molecular biology and all this kind of thing. So to say that we're going to accept a test that was not developed here in a way, it would be seen as us falling behind, right? Maybe that's one reason. Another reason is perfectly acceptable too is that the CDC has always designed assays that are very good. So it is also possible that we just assumed that it was just a matter of time for us to have our own assay and that it would be better than anybody else's.
Mm-hmm.
It's perfectly understandable that that would be the case.
Mm-hmm.
At the end of the day though, I mean, in retrospect, right? I mean, when you look back, whatever reason it was, unfortunately, because we decided not to use that test and ours was flawed and it took us this long to get a good one running, we lost a lot of time.
Mm-hmm.
And because of that lost time, now we're playing catch up.
Right. So I understand that the test is actually difficult to use, the one that we've designed. What makes it difficult?
When you design an assay, you can have an assay that is really good and easy to run. And you can design an assay that is really good and hard to run. So it just so happens that when the FDA approved the assay that we have,
mm-hmm.
they decided that they would only approve it for one particular instrument, for one particular set of primers for that particular assay. Now, why do you do that? There's a perfectly understandable reason why you do that.
You control test, right?
Well, you control the test, but you also you control quality.
Yes.
You also control quality. You don't want people, I mean, this thing, I mean, as a geneticist, I can tell you, this is the easiest. I mean, I could design an assay in under 30 minutes. It's not that hard. But I understand why the FDA doesn't want people just running anything,
mm-hmm.
right? Because you don't know, you can't control quality.
Yeah.
Right. So it is understandable that you want to have FDA approval. Now, at one point, you also have to say, well, yes, you want to get approval, but you also have to give people an opportunity to do the necessary testing.
Mm-hmm.
So this assay is hard to run, not in part because it requires additional, okay, this is going to get a little technical. So two main reasons why it's hard to run. One is because of all the approval hurdles that you have to go through to be able to get it, right? I'll give you an example. Just a few days ago, I called UCSD. This is our university that is closest to us.
Mm-hmm.
UCSD decided to design their own assay about a month ago because we didn't have an assay and they needed something. And I called them and said, hey, could you please share that information with me? We are a testing company. We would be interested in looking into running your assay. And they basically told me, sorry, we can't share that with you, right? Now, why wouldn't they share that with anybody outside their medical center? It's because they technically, they can be fined by the FDA for running an assay that was not approved.
Mm-hmm.
And there's a number of people in that same situation. So, again, I understand the FDA is concerned that maybe the UCSD assay is not good enough, and that's perfectly understandable. At the same time, it's been delayed so long that people are concerned that we're letting this disease spread all over the place, and we have no tools to identify what's going on. So that's layer number one. The layer number two of the complexity of this assay, our assay is, and like I said, it's going to get a little bit technical. So PCR, there's a lot of different versions of PCR. Basic old standard PCR is 2 primers, 2 pieces of DNA that make copies. That's it. You run that and you look at it. The assay that was designed and approved by the FDA, by the CDC, is not that standard assay. That assay has those 2 primers, but it also has a fluorescent probe in between.
Mm-hmm.
That when those primers are making copies, they interact with this fluorescent probe that is a 3rd piece of DNA in the middle between those 2. And that probe, when those primers reach it and interact with it, releases light.
Mm-hmm.
And that's called real-time PCR. What that does is, instead of standard PCR where you have to do the whole reaction and then see what happened at the end, this real-time PCR, because every single cycle light is emitted, it gives you real-time information of how that amplification is going on.
Mm-hmm.
That is supposed to be new technology. That is supposed to be better. It's quicker because you can see it real time and everything. But as someone that happens to be an expert on that, I've even written books on it and published about it. It has a lot of drawbacks. And one of the drawbacks is that light is very sensitive to contamination. So that little fluorophore, that little light that is emitted, if the sample that you have is in any way contaminated or dirty, it's going to inhibit that reaction, and boom, you get a false negative.
So,
and that is another reason why the original assay might have failed too.
And it sounds like it's expensive.
Yeah, I love to talk about this a lot when people ask me about this.
It sounds expensive. I don't know. It just sounds like it is.
No. Well, I try to find. I'm all the time trying to find information about how much people are getting charged for this. Right? I mean, I've seen everything from about $150 to $3,000.
Wow.
Well, I'll tell you two things. I'll first give you my firsthand experience of designing assays like this on a regular basis, and I charge my clients the price that I charge them. I'll tell you this, not including labor, right? Because of course, everybody gets paid different things, but just including the reagents and everything you need to run this assay. One assay like this can cost as little as $1. Okay. Now, of course, everybody has overhead. You have the nurse that collects the sample and the extract, blah, 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 all those you have to do the analysis, whatever. But just so that you know, the reagents itself, maybe $1, right? And I'm being generous. I could easily tell you 50 cents if you really want to push it. Now, the biotech industry, just like the healthcare industry, is famous for loving to have very high profit margins. Almost any reagent in the biotech industry has at least a 95% profit margin. Okay, they make good money, and that's because these reagents tend to be very, very well protected by patents and all that kind of stuff. So you only have one or two people that have the ability to make them, so they charge a lot of money. But even with that massive markup for those reagents, you can run this assay, just the reagents, for under $1. Okay? Wow. Now, so this is one side of it. I'll tell you the other side. And I always like to use this example when it comes to this type of assays. And this assay that I'm going to talk about is slightly different. It's a little more complex, but even that assay, the reagents that you need for that assay don't cost more than $10 or $20. One of the first assays that were patented in this country is for the BRCA gene. The BRCA gene is the breast cancer gene that was first identified to cause breast cancer in women and in men, in some men. The company that patented that assay, the company that patented the gene, which is shocking, but can run that assay and charge between $3,000 and $5,000 every time they run that assay. And that assay costs $10 to $20.
Wow.
And only because it's patented.
Right.
And we could spend half an hour telling you, I mean, I remember when that first happened, and I was so angry when I saw that news come out years ago, that I was like, how is it that nobody sues this company for it? And again, I'm not going to go into the weeds for this, but that company is so powerful that they even sued the government of Canada when they tried to provide that same assay for their citizens, just because they had that patent. So the price, unfortunately, this is what happens. Okay, our government could easily say, this is something that we need to provide the way we provide vaccines, because it's something that is good for the health of the population. And then this assay will cost $5 to $10.
Right.
But that's not the case, because now it's industry that is doing it.
Right. Well, so that brings me to, just going back to the timeline here. You said in November, the Chinese discovered it. Then they also sequenced it in January, and Germany then developed the first test. it seems like we should have taken advantage of that. February, they had 811 deaths in China. February 28th, the first Facebook post about the pandemic. February 29th, first death in the United States. March 8th, we had only performed 1,800 tests. And we're March, 26th today, 27? And we have barely tested anyone. Yesterday I was at the park, and they had set up 2 tents and started to have people come in for testing. So I asked the ladies out front, I said, are they going to test everybody? And they said, no, only doctors. Doctors have to prescribe the test. So if it's not prescribed, they won't even get the test. So I don't really understand whether we're not testing everyone.
This morning, I got into a discussion online. The town that I live in has about 150,000 people. Mm-hmm. And it's mostly one political side of our political environment. So I won't say who. And somebody said, we have 5 cases here. Does anybody know how many do we have? And I said, well, the best estimate right now, by a lot of different organizations that do this for a living, is that about half the world is going to get infected. So out of the 150,000 people that we have in this city, I would say about 80,000 are going to get infected. So 5, the only reason why we have 5 is because we're not testing.
Right.
Well, we are only test. And if you had seen the reaction that I got to that statement, you'd be sad. Oh. Right? Because I was called a lot of things, right? Because I'm spreading fear. So to answer your question, unfortunately, believe it or not, even though we hear from some places that we have all the tests that we can possibly have and that we're testing a lot, we are a country of 330 million people. And as of yesterday, we've tested a little over 500,000.
Mm. So do you think sorry.
So why is it that those people that get out, set up attendant are only testing healthcare workers and things like that? Is because that's all they have. You have to be able to keep all nurses and doctors and everything clean. Because the second one of those guys goes down, and they're going down, that's going to cause a lot of problems.
So why are we? If you look at New York, the cases have skyrocketed. You have and then in California, it looks like this. Is it just because California doesn't look like it's infected because of the testing situation? Well, or is it more contained?
It's very complex. I mean, I can't, anything I give you, I'm going to give you a couple of points about that, but any explanation of comparing California to New York is, those are such complex countries, really. Right. But I'll tell you this, for example, there was a study that was done recently showing why is it that San Francisco is doing fine? And why is it that New York is doing as bad as it did? It shows that when San Francisco saw their first case, they immediately imposed an order that nobody can go out. And you see their curve was going like this. Boom, they institute the order and it just stayed flat. And they superimposed the curve for New York to the curve of San Francisco. And you see that New York imposed their order to stay inside a week later. And by the time they did that, New York's curve was already here. And once it's already here, it's very hard to curve it down. It's just going to continue going up. Now, is that all the story? Of course not. But this one piece of data, it basically shows that if you prevent this from happening or spreading in any way early enough, you get something like San Francisco, where there's almost no cases. If you don't catch it early enough and you try to do everything you can, but a little too late, you get New York.
So, obviously creating vaccines for this is very complex. led strategy for the largest vaccine maker in the world. And of course, it requires thousands of healthy volunteers. And also you have to administer the vaccine. And of course you have to watch the person for a very long time to see if they get it. So it's certainly not easy, and it's certainly not anything that could happen overnight for sure. But one thing that I was wondering about was, why didn't we use a vaccine that already exists, because it's already proven safe and effective if it already exists and it's on the market? And maybe try 10 different vaccines, and at least immediately, because we know they're safe and effective, that they already exist, they're already FDA approved. Would a strategy like that be something that you think might be reasonable?
So vaccines are very powerful tools. I mean, it's crazy to me that in this day and age, we only have 12 vaccines that we recommend that we should give to our kids. And the story behind that is, it's sad, because of course, the only reason why we don't have more, or that we always have, I mean, one thing that people don't know is that one, almost all those vaccines are always in short supply. We never produce enough. And two, the number of people that believe that the vaccines are bad for you in this country is increasing every year, right? Almost, if I remember correctly, 80%, only 80% of our population thinks that vaccines are good, that they should give it to their kids. Now, why is it that we don't have a vaccine already in place, or use one of the ones that's approved? That, unfortunately, that's not how it works. A vaccine is very powerful and very, very safe, because it's extremely specific to what it does. A vaccine. So this is how you make a vaccine. You take the antigen that you're looking at, that you want to make a vaccine against. For let's say COVID-19, you get one of the proteins that make up the protein code of the virus, and you make a lot of it, and then classically you inject it into a rabbit. And then the rabbit makes antibodies. Those antibodies are the vaccine. There's a lot of different ways to do it, but that's the general principle. You are trying to generate an immune response that then can basically immunize your body. In order to be able to have something that is going to be effective against this, you needed, if you wanted to plan ahead, you needed people working on this particular virus and vaccines against this virus for years.
Right.
Right. And we had that. I mean, we had people. I mean, I've been all over the place. I just so happens, it's pure coincidence that I used to work at the Baylor College of Medicine in Houston, Texas. And there's a guy there, and God bless his heart, that was working on coronavirus vaccines. This is what this guy does. And he had a coronavirus vaccine years ago. But now, see, this is where it gets really depressing. Just having a vaccine doesn't mean that you can start giving it to people. Right? You have to prove that this vaccine is going to be good for them and not kill them. Because remember, this vaccine is going to cause a reaction in your body that we hope is going to be positive. But that same vaccine could actually kill you. So the very first test that we do, after we do testing in animals, and we say, okay, we're not killing the animal, now let's give it to people. We actually ask as little as 30 to 40 people to do the first phase testing of the vaccine, because we are very scared that we might kill them all. We're scared that we're going to kill 2 or 3, and that's enough. Because if you're killing 10% of the population, you don't want that vaccine. Right. So this guy already had a coronavirus vaccine, and he called everybody, and say, hey, I had the vaccine. Give me $3 million so that I can test it in humans. And nobody wanted to do it. And I'm going to quote you this from an unnamed pharmaceutical company, because it's amazing. The pharmaceutical company told this guy, they said, we don't really want to do this unless this thing starts coming back year after year like the flu, because otherwise we're not going to make money.
Not going to make money, right?
So, and even when it comes back, okay, so let me, this is one of my saddest stories about this whole thing. So the flu, right?
Yes.
Everybody likes to talk about, oh, you know, this corona is nothing. The
Yeah.
flu kills 30, 50,000 people a year.
Yeah.
That's something. Corona, what, 2,000 people? That's nothing. Well, we have a flu vaccine. It's called the flu shot.
Yes, right.
And only 45% of the people in this country get their shot every year.
Mm-hmm.
And it costs nothing. A lot of places give it to you for free.
Yeah.
If the majority of us, it doesn't have to be everybody. I think the statistical number is 85 or 90%. If 90% of us, instead of 45, got the flu shot,
Mm-hmm.
we will be saving 30 to 50,000 lives every year.
Mm-hmm.
So why don't we have a vaccine for corona? One of the reasons is nobody cares. They know that they're not gonna make money out of it,
Yeah.
and they know that people are not gonna want to get it, because once we forget that this happened a year or two from now, and we're gonna have the vaccine for corona, people are gonna say, only 30,000 people are gonna die. It's not gonna get me, so they're not gonna get it. Now,
Right.
is it gonna be added to the mix of flu shots? Because see, the flu shot is a mix of a number of things, because the flu changes every year. That's why you cannot just have one flu shot. You have to get it every year, because
Mm-hmm.
the next year's flu could have a mutation that makes it a lot worse.
Yeah.
So same thing. Eventually, what's going to happen is this corona vaccine that we're going to have is going to be added to this flu shot. You're going to get it if you're one of the 45% of the people that get it. But why don't we have a vaccine? Companies cannot make money out of it. Government doesn't mandate it. People that could easily have it for free don't want to take it every year. So once you start adding all this up, it's sad that we have to basically react to something like this to say, oh, now we need a vaccine.
Mm-hmm.
But we have vaccines. And when we have them, we don't use them.
So that brings me to another question about treatments. You know, we know that, as you mentioned before, you know, you have to go through clinical trials after the animal testing, phase 1 for safety, phase 2 for efficacy, and then phase 3 for both, or, you know, you could do a fast track. On the treatment side of things, I think that, you know, personally, a good strategy would be to pick something that we already have that has already been FDA approved and try to use it for multiple scenarios, and just try a whole bunch of different things and see if a treatment might work. What are your thoughts on why we don't have a treatment, or we haven't identified one?
Now, the funny thing is that treatment is something that pharmaceutical companies are very good at coming up, right? I mean, you see the commercials on TV all the time,
Mm-hmm.
right? Oh, you can't sleep, or you have this, you have that, you have that. And they make it sound so beautiful that your life is going to be perfect once you start taking that pill. They're going to come up with treatments.
Yeah.
There's no question about it, right? Because that's where you make the money. I mean, you're going to be charging people thousands of dollars to keep you alive. Fine, right? I mean, that's where we are, right? Now, I have a hard time talking about treatments,
mm-hmm.
because I mean, I'll give you some context. I've worked at medical centers in the past, like I mentioned earlier. I've known a lot of doctors. I know that once you have enough information about medicine and the drugs that we give for treatments of all sorts of things, it's easy to start to self-medicate.
Mm-hmm.
I can't sleep, take something. Mm-hmm. I have high cholesterol, take something. Take something. Take something. My take is, and this is an example I like to give when it comes to this kind of stuff. 18 million people in the world die every year from cardiovascular disease. 18 million.
Mm-hmm.
And you ask any medical practitioner, and they will tell you, we could reduce that mortality by 90% if people eat healthy mm-hmm. and exercise.
Mm-hmm.
Right? But we don't do it. But now, do we have a plethora of treatments for coronary disease? Yes, we do. And people take it all the time with all sorts of side effects, right? So look, we could talk about treatments all over the place, and there's going to be stuff that's going to come out that, is going to help, keep those people, get them through the respiratory problem, maybe even get them out of their ventilators earlier, all those kind of things. But I have a problem thinking about all the different drugs that we're going to develop before we even develop a vaccine, or before we do anything to stop this from happening in the first place, that is going to make a ton of money to the companies that are going to develop it. And all they're going to do is going to solve that tiny little problem between the moment that you get it and before you die, so that we can help you survive. And that's it. I don't think that is, I don't think that's a solution. I mean, yes, it has to be done because, of course, we're already here and we need to save lives by treating people to protect them from basically dying. But I would say, of all the different things that I could talk to you about when it comes to this is the stuff that I know the least about.
So, we're talking about things that, we don't have a vaccine, we don't have a treatment. And we also have this problem with PPEs. Why aren't we using the proper PPEs?
Because we don't have them. I mean, I'll give you an example, just, and again, N95s are the standard issue PPE that medical doctors use. Fine. Now, what is N95? An N95 is a mask that has a membrane that protects you from 95% of the things that reach your face. Is 95% good? Is that acceptable? Sure, it's the agreed upon, this is good enough, right? Now, there's what we know of as N100s. What is an N100? Nobody talks about that. An N100 is a mask, just like N95, that protects you by 99.97% of the things that reach your. Now, wouldn't you feel more comfortable that your doctor has an N100 instead of an N95, so that N95 has a 5% chance that he's already sick?
Right.
Right? Now, of course, why don't we have N100s? Because they're more expensive. That's the only reason. Now, why do I bring that up? I live in Southern California. We have fire, right? I have a stash of N100s at home. Why? Because an N100 protects you from smoke inhalation, because it's that good at protecting you from anything coming to your face. And of course, that same protection that stops smoke from basically getting into you is way better at protecting you from a virus in a medical environment. So that's one, I could go on and on about, bottom line is what's going on right now. You talk to an average doctor, and again, I'll repeat, I used to work at medical centers. I've talked to people, I've seen them, what they do. What happens on a regular day for a doctor, right? He puts an N95, he sees a patient, and he takes it out and he throws it away. Why? Because if that patient is sick, that mask is contaminated. He's protected, but the mask is contaminated. What is going on right now? An average doctor sees dozens of patients with the same mask. So what does that do? You ask the doctor, is this good? No. But what are you going to do? I have to protect myself. Because if I get sick, all these people go untreated.
Right.
But am I spreading the disease at the hospital? Yes.
So what is your? Oh, go ahead.
No. One of the discussions that we used to have in this country for a long time, anybody that is old enough remembers what Ike used to say when talking about Eisenhower. I'm not even going to go into the numbers, but our military equipment, and again, love our military, right? That's what it's part of our national pride. We have a great military, great people. Now, we spend a lot of money, and fine, let's spend a lot of money. We need to protect the country, fine. But imagine this. A fraction of 1% of that money could fund everything we need to have a stash of all these PPEs and way more, ventilators, et cetera, everything, ready to go if something like this happens, right? But we don't do it, right? Now, I could always argue, there's a lot of waste, this and that and everything, but bottom line is, we have different priorities. Mm-hmm. And, medical doesn't seem to be one of them, even though we spend twice as much per citizen than the rest of the world, and we get what we get, right? So yeah, to go back to your question, PPEs.
Could you describe what a PPE is, just for the audience?
Sure, it's a personal protective equipment. So it's everything that you do to protect yourself from getting infected, right? For example, a doctor goes to a room, he doesn't put one glove, he doesn't put 2 gloves, he puts 3 gloves every time. Why? Because that glove that is touching, once he's done, goes. But he goes using the glove that touched.
Mm-hmm. Right.
Right?
Right.
So this one removes that one that is contaminated. Now this one is clean. This clean one removes this one that was contaminated, right?
Right.
So now you're clean.
Yeah, right.
Now, are we doing that right now? No. How many gloves people are using? 1. What does that do? You remove this one, you're already contaminated. Mm-hmm. Okay. Now, suits, it starts getting more and more expensive, right? Hazmat suits. I mean, you see any reporting of what's going on in Japan, Germany, Italy, South Korea. What do you see? You see people in full hazmat suits with multiple gloves and masks and everything. What do you see here? I mean, I'm not saying every place is bad, but I see trash bags. I see masks that have been sterilized 2 or 3 times that are falling apart. I mean, that's what I mean by PPE. We don't have what we need. Even California, which tends to be a little bit better prepared, maybe, all we had was about 20 million N95 in our reserve. What is 20 million N95s? That's 2 or 3 weeks of work, and that's it. Now, of course, you can give, you can understand, right? Nobody expected this from happening. Fine. Will we learn that it can happen now, and will we have better resources in the future so that we don't have to scramble around to try to see where we can find these things? One thing that I always like to point out, for example, I always focusing on these masks. People like visuals. The machines that are used to make this mask, you think a mask, I mean, what is that, right? You hear all these anecdotes about people sewing things and all that kind of stuff, which, by the way, better than nothing, but a single machine that is used, a single one, that is used to make the membrane that goes into one of these masks costs millions of dollars. You think, what? A little membrane? It's a very special membrane. We're talking about membranes that are so fine that it can stop a virus, right?
Right.
And it typically takes close to a year to install that machine before it starts working, right? Now, again, this is all, I mean, this sounds crazy, but this is all, if you plan ahead, if you actually fund the necessary resources, thinking that this is gonna, and again, this is, I mean, I understand that some people think that this came out of the blue. I guess we have very short memories. This happens almost to the T about every 10 years. Sure, this one is especially bad for a number of reasons. We're not, I'm not gonna start pointing fingers, but we get them all the time. We just forget. And why didn't we do what we needed to do before? And why didn't we do what we needed to do before that? We can easily have all this in place. We just don't.
So, I know a lot of the factories are repurposing them to make ventilators and PPEs and so on. Do you think we're going to run out of the PPEs and the ventilators?
I'm going to sound like I'm spreading fear, but almost for sure. I don't see how it's not going to happen. And the only reason why that is because right now we're nowhere near how bad it can get. Let's hope that it doesn't get bad, okay? It's very good to hope. Pray. Let's pray it doesn't happen. But any model that you see, all the data says it's gonna get bad and it's gonna get much worse. If it gets where it could get, if it gets where it's going, we are gonna run out.
So what do you forecast? I mean, so we've been, just for as a background, we've been working on we were working on this investor forum that we were going to have in Arkansas, actually, with the Walton family, and we canceled it, of course, because we don't want to have people get sick. If one person's sick, they could all get sick. So we did a lot of analysis in this area to try to figure out, should we have it? Should we not have it? So we listened to a lot of experts, and one of the experts, or I guess a couple of them, are forecasting that this is going to mutate very quickly, and in the fall it will get much worse. I'd like to hear. No, you don't think so?
Actually, we're lucky. All the studies so far shows that we're only getting about 2 mutations a month, and that is low. That is low. So again, all it takes is 1 mutation, right? And if you're unlucky enough, you get the right mutation, yes. But just based on experience, it's mutating slowly. So we might get lucky and nothing happens. Meaning it's not going to get worse than it already is, and then it's already projected to continue getting worse because of cases and that and stuff.
So what do you project in the next 12 months?
Let me start by saying this. So if you look at all the professionals that do the estimates, right? One of the things that they just added to their models, this is, you look at all the models until now, and now the new models are going to start coming out. One of the new variables they just had to add was, is this a hoax or not? Okay, they've had to add to their model whether people believe this is true or not, because it all depends. If people believe this is real, and again, we're seeing thousands of deaths now. We're almost at 30,000 in the world, right? If people continue believing that this is a hoax or it's not true, and we reach 100,000, 200,000, 500,000 deaths, then the models are saying this is going to get much worse. But if somehow the majority of us, it doesn't have to be all of us, but if half of us doesn't believe this is true, it's going to get worse than it should be. If a majority of us starts to believe that this is real, and it could get worse, then it's not gonna be as bad. People will start doing what needs to be done, staying home, and that will slow the spread. You slow the spread, you never get enough people at hospitals to overwhelm the system, and it's controlled. But there's a tipping point, right? If you don't control it enough and it gets past that tipping point where hospitals in New York or Louisiana or whatever get overwhelmed, that's the equivalent of when a dam overflows. As long as the dam is there, everything is fine and it doesn't look that bad. The second it overflows, all that water goes everywhere. And that's what could happen if we let it overwhelm the hospital system. So again, right? Most people don't think that that's going to be the case, right? I'll give you a quote from one of the doctors that I just read in the Atlantic yesterday. They did a profile of one of the doctors in New York. He said, China warned Italy, and Italy didn't listen. Italy warned the United States, and we are not listening. So what that says is, if we don't do anything, we're going to look like Italy in the future. And what is Italy? Italy is, and they have an amazing healthcare system. Okay, the town that got overwhelmed is the town that builds Ferraris. They have an amazing. When you sell $500,000 cars, you pay a lot of taxes. Your healthcare system has everything they need and more. But because they did not act fast enough, it got overwhelmed, and you see 1,000 people dying every day now, right? So where is this going to go? Unfortunately, it's anybody's guess. On the positive or the least best case scenario, we will control the curve.
Mm-hmm.
It will continue going for weeks and even months, but it will never get to the point where we start getting a lot of deaths.
Mm-hmm.
But it's not that hard to imagine that we start getting more deaths to the point where it overruns the system, and then that's when the number of deaths starts spiking, like they are doing in Italy.
Hmm. So we talked a little bit about New York earlier, and you mentioned that, they didn't quarantine really a week later than California. But it is an epicenter, so maybe it was because they were late in responding. Why are they an epicenter? Is the only reason they're an epicenter is because they waited a week?
No, I mean, there's a lot of reasons. I would say that waiting was one of the reasons, maybe not the top reason. I would say that unfortunately for New York, one of the strengths of that city is actually one of the reasons why they got hit hard is New York receives millions and millions of tourists every year.
Yeah, right.
And a lot of Chinese, right?
Mm-hmm.
I mean, just do the numbers.
Yeah.
Let's say 0.01% of those Chinese tourists had the infection.
Mm-hmm.
That's it.
Yeah.
Right? Nobody can control that.
Yeah.
Nobody can control that. So now, does California get a lot of tourists too? Sure, we have a lot of Asian population here, but we are a lot more spread.
Yeah.
Right? I mean, you look at LA. LA is the second largest city in the country, right? But New York is like this.
Mm-hmm.
LA is like this.
Mm-hmm.
So just because I mean, it's bad for the environment because everybody drives and we have terrible air pollution, blah blah blah. But sadly, that protects you.
Mm-hmm.
Right? New York is just I mean,
compact.
The subway system. I mean, God, it's a wonderful thing to have.
Yes.
But it's the perfect place to spread.
Yes, I know. Between 7 and 9 in the morning there, you can barely get in. They pack them in. If you touch one person, you're done. That person's holding on like.
So, I mean, all the things, I mean, New York is an amazing city. They have so many things going for themselves. A lot of the same things basically backstab them. It's essentially, it's almost, I mean, I like to equate it to nuclear energy, right? Nuclear energy is an amazing thing, right? It's cheap energy. Yes, it has some pollution problems, but it doesn't produce that much greenhouse and everything until you make a bomb, right? And then all of a sudden it's like, well, that's not as good anymore. Everything that New York has, from their transportation system to the fact that people walk instead of drive, it's a lot of good things, but that happens to be one of the ways that this thing spreads a lot more than other places.
And what about New Orleans?
Mardi Gras.
Right, probably lots of visitors from out of town, right? I
mean, the sad thing is that in a couple of weeks, you're going to start seeing reports that are going to show everything was fine, and then everybody showed up for Mardi Gras, and then you're almost going to be able to connect to the T, the moment that guy went to Mardi Gras to the moment that people started getting sick. There's way too many people in, Mardi Gras. It's Mardi Gras.
Right.
I mean, if you think the subway in New York is bad, being in Bourbon Street in the middle of Mardi Gras is 10 times worse.
Yeah, it was the interesting Boston conference where the Life Sciences Organization held a conference of 100 people, and 70 of them were sick afterwards because they came from other places. And, actually what's really interesting is that the cherry blossoms are out in DC, and a lot of people have come to see the cherry blossoms. And they're all over the place. There's people walking around looking at the cherry blossoms, and they're gorgeous. I'm looking at them from outside the window, by the way, because I have them outside here. But the police actually had to come and tell people to leave and not be around the cherry blossoms. So going back to your point on the hoax, I think it's a very important consideration. Some people,
Yeah. Yeah, I mean, I love cherry blossoms. I mean, I mentioned that I'm first and foremost a farmer.
Yeah.
I live in 120 acres here in California, and I grow everything. And the moment that the cherry blossoms start blooming, I have a bunch of cherry blossom trees here. And one of the amazing things about flowers, blossoms, is that it's just their way of reproducing, and they put out a lot of pollen, right? And you don't see it many times, right? But if you have any kind of allergy, you immediately know when the season is,
right?
whether it's cherry blossoms, or whether it's grass pollen, or whether it's any kind of pollen throughout the year. Now, the funny thing about pollen is that it's way bigger than the virus, right? Now, if you ever look at videos that show you what happens when those blossoms open, that whole area around the mall and everything is a cloud of pollen.
Yes, right. It is a cloud. Yeah.
Right. And this is exactly what we're talking about when we talk about a spread of disease. Now, the pollen is a beautiful thing. It's going to produce cherries and everything and all that kind of stuff. But it's a perfect metaphor for this is what's happening. You go outside, and you're going to have pollen all over you. You don't notice it, right? You don't even smell it. You go take a shower, and it's gone. That's exactly the same thing that happens. I mean, you don't see the virus, but it's everywhere.
Right. So, what do you think are the largest areas of unmet need right now? For example, one thing that I think about are elderly people who need care. Caretakers are not coming to their houses because they can't, or they need to stay away because they might infect the older person. And so this older person still needs care and medication. There might be a way to get the medication to them, but we have a lot of areas of unmet need right now. I'm just kind of curious about your perspective on the areas we're really not addressing yet.
I would say first and foremost is hospitals and the healthcare system. I just saw this week, New York started this coronavirus search force, right? And the governor said, hey, anybody that wants to sign up. And they had like over 40,000 people sign up, including people from the private industry, including retired people that are coming out of retirement. Again, we cannot talk about containment anymore. We are talking about reacting to this thing, and we're trying to plan ahead. All we can do right now is plan ahead for what's going to happen. And what's most likely going to happen is we're going to get a surge. And we need to protect our hospital system from being overwhelmed. And one way to do it is to have enough people to deal with the surge. So what New York is doing, I mean, I cannot think of anything better than that. You put the word out. I mean, here in California, I'll give you an example. Because we shut down everything, we have 14,000 nurse students that cannot graduate, that cannot help out, right? Because they can't graduate because the university is closed, right? Now, we in California, one of the bad things we have here is that people love to sue everybody. That's just the way it is, right? And so what does the government do? Like, oh, do we tell all those 14,000 students, sure, you can start helping, but what if one of them gets infected? The very first thing that's going to happen is the parents are going to sue.
Yeah, right.
Exactly. And then that just the suits alone is going to stop the process. It's too much of a distraction when we cannot afford that. So what New York is doing is exactly what I believe. I mean, there's a lot of things you can do, but doing anything you can to prepare for what's going to happen. And the belief is that we're going to get a surge, get enough people prepared, be part of the system so that when we go from 1,000 people at the hospital to 10,000, we have the people ready to treat them. And the other thing is, and again, I'm a little biased in this one. Right? To me, testing is critical. Right now, a lot of what I see as far as people saying, well, this is not real and whatever, is that we're not testing enough. Like you said earlier on this talk, we only tested less than 2,000 people just 3 or 4 weeks ago. Now, 500,000 now is good, right? It's better than nothing, but we should be in the millions by now, right? Now, why is testing important? I'll give you an anecdote. LA County, about a week or two ago, put out an order saying no more testing because we don't have enough tests. Yeah, they said no more testing. Why? Why? Because they don't have enough tests. So they focus the few tests that they have to keep health workers safe and healthy. So they're not doing what is testing to try to understand what's going on. Right? Everybody's being told, you feel sick, don't test. We don't have enough. Are you concerned? You are healthy, but you're concerned. You want to protect your family. You want to make sure that you're not sick. Don't test. And I understand. If you don't have tests, that's what you do. But let's imagine for a moment that we really have a lot of tests, right? Because right now we're blind, right? We're blind. We don't know what's going on. Anybody that tells you we know what's going on, even the experts saying, oh, we have 100 and some thousand confirmed cases, and we've tested 650,000 people. All that is a drop in the bucket. We don't really know what's going on. You ask somebody in Oklahoma, what's going on there? Or Florida, or Ohio, whatever it is. You do not know what's going on. New York, maybe a little bit. Here, maybe a little bit, right? 650,000 tests for a population of 330 million is a drop in the bucket. What we really need to be doing, and we're getting there. We are, I'll give credit where credit is due. We're definitely ramping up. We need to be testing a lot. Why? Because if you test enough, you will be able to start seeing what really is going on. And unfortunately, very likely, what we're going to see is that this has spread everywhere. And once we see that, that same data will tell us these are the centers.
Right.
And we're going to do something about those to stop it. Right. And little by little, we will be, taking out fires here and there and there and there. But until we have that information, we cannot do that.
Right.
Right.
And I think about the story of Typhoid Mary, when she was a cook and she fed the men and killed them all, or not all of them, but a large percentage of them because she was a carrier, but she didn't have any symptoms. So all of us could be carriers.
Yeah. Oh yeah. I mean, I every time I talk to people, I tell them to get close. Right. Oh, because you're going to get it? No, because I could give it to you.
Right.
Right. I mean, you have to think of it that way. Now, I'm never exposed to anything. There's no chance I have it. But you should always assume, you should always behave as if you were. Better safe on the side of caution than to be proven wrong. That's, I think, the best thing you can do at this moment. And to follow up on your original question, what do we need to do? Unfortunately, I mean, it's not top priority because, of course, health, medical hospitals and everything need all the support they can. Stop. Testing is definitely very important because until we actually start doing enough, we're blind. But education. I don't know how you do it. I'm an educator myself. I used to teach. I don't know how you do it. I've tried, but I don't know why people are so vested in the idea that this is not real. Vested in the idea that this is not a big deal, that it's just simply going to go away. And let's say it does. Let's say at the end of the day, we only have best case scenario, 50,000 people die. We get, 10, 20 million cases, whatever it is. If we do what needs to be done to try to stop it, and we are wrong, and it doesn't do us much harm anymore, at least we can say that we did everything we could. But if we don't do anything, it's like not having insurance. If something happens and you have insurance, yes, you paid all that money, blah, blah, and nothing happens, well, I'm out of money. But if something happens and you have insurance, at least you're covered.
Mm-hmm.
right? And then you're not in a really bad situation where you're like, well, what am I going to do? I don't have the money. So I think very important. How do you do it? I really don't know. How do you try to convince half of the country that doesn't think this is important? I don't know how you do that, but that I would say is up there on the list of things that need to be done.
One other thing that we've been thinking about is trying to create like a single source of truth, because there's a lot of different conflicting information out there, misinformation out there, and some are wanting to take advantage of the situation and flooding the different media with different, as I mentioned, overlapping, conflicting concerns, ideas, whatever it might be. And so, we think that there should be a platform where we can actually peer review information that is, we know is correct about the supply chains, about every aspect, about policy, about every aspect of what's going on right now, because there's different dynamics. What would you say that people should be doing now?
Well,
cities, countries,
sure.
people.
I mean, I'm going to assume, and I'm only going to focus on the United States. I'm going to assume that we are not going to have a national shutdown. Even though that's what we should do.
Mm-hmm.
We have about a little over half a dozen states that are already doing it.
Mm-hmm.
The rest of the states are not doing that. The president could easily say we need a national shutdown, period. Most experts believe that that's what we need to do. Bill Gates just the other day said shutting down individual states and have the rest open is not going to work.
Mm-hmm.
And I kind of agree with that. So I'm going to say it's never going to happen. Now, let's say the next best thing is just to shut down individual states, as we're doing. Unfortunately, yes, it's happening, but it's not going to work. The next best thing then after that would be stop travel from state to state, so that when you have one state that already took care of their problem, you don't bring new cases from a state that didn't do anything. Again, it's not going to happen either. I mean, I hear all over the place people saying, okay, we're in quarantine. I guess nobody's flying, right? You have no idea how many people are still flying. We're flying everywhere.
Mm-hmm.
As if nothing is happening. Sure, the airline industry is saying that they are about to go broke and everything. But if you look at on any given day flight tracker data, we have planes everywhere all the time. They say some of them are cargo, sure, but most of them are passengers. So as long as, yes, you can isolate California, but if Arizona starts sending their people and they're not even testing, and God knows how many people now are states trying to get even beyond that. So okay, so that's not going to happen, right? We already approved a $2 trillion package to keep airlines and everybody else going for maybe 2 or 3 months. So the last thing we're going to do now is stop the airline industry from having even fewer flights.
Right.
So what are we doing now? Well, the governor of Florida just said we are screening every single person that comes from New York, right? So people are going to start doing more of that.
Mm-hmm.
Is that going to help? Again, most likely not. When our government stopped travel from outside, like when they imposed travel ban to Europe,
Mm-hmm.
and then you saw everybody rushing to come back, and you had airports full of people just infecting each other, trying to get through, right?
Right.
And what was the story at the end? You had all these other people coming back from Europe and other places saying, yeah, we saw that line there, but we were coming from the Philippines, or we were coming from this or that and that, and nobody told us anything. And we just went through.
Mm-hmm.
So yeah, you stop the few cases that were coming from Europe, but all the other cases coming from everywhere else came through anyways. So, that's not going to happen either. And even if it does, it's not going to work. So all I can say is people just have to take it their own responsibility. The best thing you can do right now is hunker down. I know it's hard. Right? Nobody likes to stop their lives, but we have a very good life in this country.
Mm-hmm.
I mean, it's a very very rich. We don't want for a lot of things. So try to keep yourself out of being exposed to others. Try not to be out so you expose others to yourself. Don't go to the hospital. That's a critical thing. Even if you feel like you're sick, don't go to the hospital, because what's going to happen is let's say you don't have the infection and you feel like you have the flu, because of course, we have flu cases. You go to the hospital, you don't have COVID-19, you go to the hospital, the guy looks at you and says, yeah, you're fine. Then you get the infection from the hospital, and you go back home and infect everybody, right? So don't go to the hospital. If it gets bad, when you're at home and you get sick and you get bad, then call your doctor and ask him what to do. So it is, we are at a point where the best thing you can do is just take things, take it seriously, stay away, self-quarantine, and just wait it out.
So what do you think the new normal is going to be?
Man, I'm going to come across as a very negative person. I don't think there's a new normal. I don't claim to have a great memory, but I remember H1N1. I remember Ebola. I remember Zika. I'm a student of history. I've studied past epidemics, what we did, how people used to think, what people used to say back then. And if there's one pattern, is that we never do anything about it. In a couple of years, most people will have forgotten this. So I would say that the new normal is business as usual. Sad, unfortunately. Now, having said that, let's remember, and again, not to be political, this happened because, I mean, again, typically, historically, or irrationally, the president is the person in charge, right? The buck stops here. So who is in charge now? He's the one responsible, and that's what happened. Who was in charge when H1N1, swine flu, Zika, Ebola was in charge? It's a different president. What happened then? Nothing happened. There was no crash. There was no quarantine. There was no cases. I mean, everything was taken care of the way we can easily take care of this, even when we're not that well prepared. So I think that we're going to continue going in cycles of bust and repair, bust and repair. Some argue that that's a good thing, because doing the same thing all the time historically is not a good thing. But the sad thing is that when something like this happens, people like you and me are not really that hurt. The people that get hurt are the people that have day jobs, that have to pay bills every month, and if they don't have that job, they cannot pay those bills. And if that alone, I believe that alone should be enough reason for us not to let this happen again. But sadly, I don't think it's going to change.
Well, I want to thank you very much for your sharing your perspective today with everybody, your very valuable insights, and I'm very grateful for your time. Is there anything else you'd like to leave the audience with who are listening today?
Sure, I was just thinking that please don't leave it, let's not live in such a negative note.
What's the positive at the end of the tunnel?
Right. I want to say that I'm a scientist, so we are very rational people. We tend to be very analytical. So we sometimes fail at humanizing things. I also happen to have grown in a part of the world where the vast majority, almost all people are very religious. So I'm a person of faith. And my faith dictates a lot of the things that I do. So I like to tell people the following, which is, if I just were to base everything on facts and data, statistics and estimates, it's very easy to be very negative and very, maybe even depressed. But I have faith that despite all those things, things are going to be better. I might not be able to give you numbers to prove that, but I have faith that things are going to get better. And that while I don't believe there will be a new normal and that we're just going to continue business as usual and that we're not going to learn from this, I do have faith that one day I'm going to be proven wrong.
Okay, wonderful. Well, Ivan, thank you so much again for your time today. I'm really grateful.
Sure. Thank you.
All right.